Hello guys, welcome to today's video where we are going to discuss about K nearest neighbor algorithm. So we're going to deal this with a very simple example which we use in day-to-day life, and we see how this can be applied in a project and so on. So in most videos they do not really tell about how we can use the KNN algorithm or what are the practical applications. They directly start with this kind of chart which you see in the middle of the screen, and they start explaining what this algorithm is about. So but it's quite complicated than how or what it looks like in this simple graph here. This graph is just for pictorial representation for the user and for the people who evaluate and analyze and for testing purpose, but this in real life is not really visible to any user or even for the developers once the KNN algorithm is deployed by piece of a software into any system. So in short, before we start with applying this algorithm, we need to do some kind of data preparation. So in this example, we are taking an user application, which means a video or audio player, something like a YouTube or a soundtrack recommended audio player or TikTok or Reels and so on, where we're trying to play a video based on user choice. So we categorize mainly for simplistic purpose. We categorize here in this example just two kinds of songs that we have and soundtracks. One on x-axis and one on y-axis. We try to map the features, and then based on those features we are trying to plot this soundtracks. Yeah, each one of these dots is a soundtrack and it has certain features. On the x-axis we see, for example, we have a tempo and the rhythm, and the y-axis you have the axis x2 we have the pitch and then loudness or the amplitude of the song, based on which, for example, we are trying to plot the nature or the characteristic of this soundtrack. So when we plot, we get in these positions, and then further this is kind of a preparatory step, and where we try to group this and we come to understand, okay, classical songs fall in this category of these features or these characteristics of the x-axis and y-axis, and jazz songs fall in this. So with this basic understanding, we try now to recommend a soundtrack to the user. So the user is now tries to play. He basically did a subscription, he did a small sign up, and during the sign up he has some basic idea of what he likes and dislikes, and he gives this as reference data. Now as the company which is owning this soundtracks and trying to play this audio or video tracks, now is taking one of thousands of video and audio tracks that they have, they're trying to play this. Now they recommend one of this. Now what the algorithm does before playing them is that it filters, it categorizes. Let's say, for example, the user likes classical songs, and based on the reference data, which is not very explicit at this point whether he likes classical or jazz, we come to the assumption based on this algorithm, by taking this reference data, we try to analyze the song first and then play the song. So one of the songs or one of the soundtrack we take, and with this comparison we try to classify whether this song falls as jazz or classical. So, and after the classification, we basically recommend or de-recommend. We declassify it and we put it in the place, and the user scrolls up or down and plays the next track, and where the user is trying to get the idea of, oh, this song is not classical or classical, and so on, and he plays the song or rejects the song. This data is collected once again and is kept as a reference data or historic data, which is used by the algorithm for the next time when similar song comes in. So this cycle or loop is done several times. So the next song comes in is being classified, and then either we recommend or de-recommend, and this goes on and on. And in this due course, we try to collect a lot of data, a lot of historical data about the nature of these songs, and then these features are attached to these songs, and then once again they are stored or saved in the database, we attribute this feature or these characteristics to each song. So what about those songs which do not have a clear-cut classification, which does not fall either here or here, for example this one? In that case, we do some kind of trial and error experiment. So we send to the algorithm, and he classifies, and the algorithm takes a risk of recommending this, and then we recommend this to the playlist, and now the user is trying to, it's kind of a voting. So there are several users. Some of the users define this as, or who are strong classical listeners, like the song and they play this song, then the algorithm for the next time it learns intelligently that this song to be classified as classical and groups it to this cluster. Or if the other way around, many of the classical users do not like the song, then it declassifies it from classical and then put them in jazz group, so that the jazz listeners can in the future be recommended for this song. So this is how, in short, we do this KNN algorithm. So how we can apply this in real life or in any kind of recommendation or any kind of application which has multiple groupings of songs or categories. We can use this KNN algorithm. So in this example, we try to keep it simple, not make it complex and feature just X and Y axis. We can do this for multiple dimensional axes and have more and more characteristics based on which the user can select a song, and we recommend the song as an app developer. So in the next cycle or next video, I would explain you about different life cycles which we have for machine learning and data science development life cycle, and we will do a comparative study of different frameworks available, and then we will see which is the best one to choose from the existing frameworks for your particular project or your wish of development life cycle. So thanks a lot guys for listening to me, and then see you in the next video, and I wish you a nice day and catch you soon. Bye.